Okay, this second half we're going to talk about computers. A computer is a device that processes information using electronic circuits. Data is any individual piece of information that might be processed by a computer. Computers have a great capacity for processing enormous amounts of data accurately. Computers can perform literally billions of calculations per second. So we start out with the simplest way of doing calculations, and this was called an abacus. It was a series of beads that could be used for counting and calculating. And this is what an abacus looks like. A slide rule, as I've talked to you about before, was a common device that was used during my time in high school for doing calculations. And this is a slide rule. Mechanical calculators came along, and they were devices that, like slide rules and abacus, that could perform calculations using mechanical rather than electronic means. So mechanical calculators did their work mechanically. The first computer was called an ENIAC. An ENIAC stands for Electric or Electronic Numerical Integrator and Calculator. It was invented in 1946 as the first generation of electronic computers. The UNIVAC-1 stands for Universal Automatic Computer. It was developed through the learning process that occurred during the ENIAC development, and it became the first mass-produced computer. And here's a picture of the UNIVAC-1. So on the left you have the ENIAC, on the right you have the UNIVAC-1. Now, you can see down at the bottom of this computer tree is the ENIAC, which was the first computer. And you can see that things have developed quite rapidly. And the farther out on this tree you go, the much more complex and useful the computers have become. And also notice that the dates here, we're only out to the 1960 by the time we get to the very edge of this tree. So in 14 years, we had this much development. So from the point forward, the goal was to make the same machine smaller and faster. And better electronics led to these better changes. You remember in the last section, I talked about the various developments that went from diodes to triodes, vacuum tubes to semiconductors. As those developments came along, then changes in the computer also developed. So all computers are based on very simple circuitry. Now, you have to understand something about data in order to understand how computers work. There's essentially two types of data. There's analog data and there's digital data. And analog data is data that can have any possible value within a specified range. And an analog clock is shown in the picture with the numbers and the hands. That's an analog clock. And the analog sound wave is shown and labeled. And so at any point on the clock or on the sound wave, you can have any value that you want. There's an infinite number of values on an analog sound wave or on an analog clock. Digital is data that can only have certain values within a certain range. So this digital clock, you can only have values that are digitally expressed on this clock. Now the clock can be very accurate and read out to hundredths or thousandths of a second, but it can only have specified values. And you can see by using these little stair steps that a digital sound wave also can only have specified values. So almost all, and I would say probably by now, all modern computers are digital computers. That is, they work with data that has expressed values as opposed to any possible value. So the reason this is important is because it's built on a decimal system or a numerical system. Now, our system is a decimal system that's built on the powers of base 10. And you understand what that means. That means 10 to the 1 power is 10, 10 to the 2 power is 100, 10 to the 3 power is 1,000, etc. Computers are built on binary system where something is in a power of 2. So it's 0, 1, 1, 1, 1, 2, it's 1, 0, 1, 1, 1, 1, 0, etc. You can only have a value of either 0 or 1. The reason this is important is because a system is either off or it's on. So if it has a value of 0, it's off. If it has a value of 1, it's on. So data is represented in a circuit of a digital computer by either a 1 or a 0, by either being present or absent as pulses of electricity. A byte is the smallest directly accessible unit of data, which consists of a group of 8 bits. And so here we have 8 bits of data. They're either 1 or 0. And as you can see, this 8 can have multiple combinations. When this 1 byte of data is translated, it's translated into on-off signals. In this case, 4 on signals, 4 off signals, 1 on, then 2 off, then 2 on, 1 off, 1 on, 1 off. And you can see that each time the data changes, this sequence of 1s and 0s changes and the ons and off changes. Now, to translate this for humans, we moved this to what's called a hexadecimal system. The binary system is difficult for humans to read, so it is translated to powers of 16, which is called hexadecimal system. And that's this system right here. So the hexadecimal system looks like this and is translated this way from the binary system. Now you may have heard of ASCII, A-S-C-I-I. This stands for the American Standard Code for Information Interchange. It's the most common coding language used to transfer numbers and symbols into the binary language that computers use. And this is an example of a ASCII code chart. Obviously, you're not expected to remember this, but everything can be translated into zeros and ones from other types of data. The Unicode standard, it uses a requirement of 4 bytes of data in order to store each particular character. So a character, 6 for example, or a B, is translated into 4 bytes or 32 bits of data, or 32 bits, and that is then stored as a character in the computer. And this is just an example of the Unicode standard. So most computers operate on the Unicode standard. And this is all discussion of how computers change the very complex language that we use to communicate into numerical language, which then can be translated into series of on-off switches that the computer uses to do the calculations. So at the top you start with a bit. 8 bits are a byte. 1,000 bytes, 1,024, is a kilobyte. Then you've heard of megabytes, gigabytes, and terabytes. So when measuring computer data, the SI system usually gives a slightly different meaning based on the powers of 2. That's why a kilobyte is not exactly 1,000, it's 1,024. So a kilobyte is 1,024 bytes based on powers of 2. A megabyte is 1,024 kilobytes, or 1,048,576 bytes. Now, this is an example of computer logic. So logic gates are devices that produce a single output from a combination of inputs from various diodes, transistors, or other components. So a logic gate changes multiple inputs into a single output depending on what kind of command you give the logic gate. So AND means that the gate fires only if two bytes are both true. They have to both be true. Or, on the other hand, will fire if either of the 2 bytes are true, and will not fire only if both bytes are false or off. So different combinations of these logic gates allow the computer to perform a variety of mathematical and logical operations. Now, you've heard the term CPU. So the hardware of a computer, when you talk about a computer, you can divide it into two things: hardware and software. Hardware is the actual physical components that the computer is made of. And this hardware is divided into processing, which is the CPU. CPU stands for Central Processing Unit. Memory, and then input and output devices. And we'll talk about each of these individually. So the CPU, or Central Processing Unit, is the device that controls all the other functions of the computer. It is the brains of the computer, if you will. And a microprocessor is when you put all of this brain into a single chip, and so it's called a microprocessor. Multi-core processors are when several CPUs are put together in a single chip. And so in this situation, you have 2 processors that are built together and attached together in a single chip. Parallel is dividing the processing between multiple CPUs in a multi-core or a multi-processing situation. So you can divide the processing power between CPUs. Now, moving to the second part, which was memory, you have what's known as random access memory. Random access memory is the area of storage of information that's on a temporary basis, but it is what the computer immediately uses for whatever it's doing at the time. So this is memory that's immediately available to the processor, and it is there only temporarily. And so the computer is continually moving information in and out of the random access memory. And the size of the random access memory is important because it controls how much the CPU can do at any one time. And so what you have is 2 types of memory. You see on the right here, you have the random access or read-only memory, and then read access memory, and then the ROM, or read-only memory. And this is the long-term memory, and the random access gets its information from the read-only area, and it goes back and forth. And this is why the human brain and the computer are very similar, because we can only work on certain things at one time, and this is what we call working memory. What the computer calls random access or temporary storage is what we call working memory, and that's whatever is immediately available for us to use in our processing. But then we also have long-term memory, just as the computer has permanent storage areas. And the key is to be able to move things from long-term to working memory on our side, and for the computer to be able to move it from permanent storage to temporary storage. So ROM, or read-only memory, contains the basic information to start and operate the computer. And then the storage devices is the long-term storage areas that have the large amounts of memory. So when you buy a computer, you essentially buy 2 types of memory. and you pay more. And one is how much the long-term memory you buy. And, you might buy 128 megabytes or 256 or 512 or 1 gigabyte, for example, or whatever. And then also how much random access memory you have. If you want to play a game that is very complicated, you need a lot of random access memory in order to operate that game. Now, hard drives are drives that have the long-term memory, and they can use a spinning disk or a disk to do that, or they can be optical, or they can be flash memories. And one new memory type that is not included here is the solid state memory that many computers, smaller computers, have now, that it has more rapid access. So on the left here is an optical disk, and on the right is a flash memory drive. Now there are all kinds of, so that's memory and processing. The last of the hardware here is the input devices, and you have all kinds of input and output devices. You have a keyboard as an input device, your zip drive input device, you can have a mouse as an input device, you can have a video camera as an input device. Output devices include your printer, your monitor, your speakers for sound, and so forth. So the keyboard is the simplest and earliest input device. The pointing device or mouse came along after that. And then the video display was the first and earliest output device. Now modems, which stands for modulator demodulator device, it converts digital data into analog data and back again to be transferred across phone lines. So this is an example of a modem. And a modem is used to transfer analog data to another distant area. A motherboard is just a circuit board that connects the computer's components. This is an example of a motherboard. Now, software, we've been talking about hardware. Software is all the programs that direct the computer and tell it what to do and how to do it. System software is the underlying software that does the basic operations that the computer does, and it's generally called the operating system of the computer. And then the application software is all the other programs, things like Word and PowerPoint and Firefox and various other types of software that we use. Now, machine language is the form in which the program is written so that the computer can understand it. So what you have on the left here is the human problem, what you want to solve. You write that out in human language. It then has to be translated into a computer or machine language for the machine to be able to understand what you're talking about and give you an answer. It gives you an answer in computer language, which then is translated back into human language for you to understand it. The programming language is the way that we communicate with the machine so that the machine understands what we want, and it's the way the machine tells us stuff so that we can understand it. Now, this is an example of a network. And computer networks are just linking together several computers. Now they can be local, a LAN, which stands for local area network, or they can be global, which is what the internet is. So worldwide networks of computers are called the internet. So when you plug into the internet, basically you're plugging into a network of computers all over the world. Cloud computing is a situation where the internet is accessing remote computers, and it goes through, it's called the cloud because it's transferred digitally across satellites and so forth. We'll end up by talking briefly about servers. A server is a computer that can be accessed by many users at one time, so that many users can use the same hard drive and the same email service and the same file service, and so that you don't have to pass flash drives or disks to each other in order to transfer files. And this is just an example of a server system. A mainframe is just a large computer that's designed to store and process massive amounts of data. And a supercomputer is a computer that's large and extremely fast and able to do enormous numbers of calculations at any one time. And here's an example of the Titan supercomputer. And there are various types of supercomputers.